video, I'm going to talk about how can you solve a system of equations by graphing. So we start by first of all defining what do we mean by a system of equations. A system of equations is a set of equations that work together, and a system of equations that has only linear equations is a system of linear equations. And on top of that, if the system of linear equations has only two variables, then we say it's a system of linear equations in two variables. So it is this last kind of linear system of equations that we're going to be talking about in this video. So we will see how to solve a system of linear equations in two variables using graphing. So here are two examples of what a system of linear equations in two variables looks like. Both of those examples have two equations each, and both the equations have the same two variables. Now, what does it mean to solve a system of equations? It means to find a point or points that satisfy both equations. So the solution of a system of equations is a point or points that satisfy both equations. So let's see an example to understand. So it says there are these two these two equations, and it says the point 6, -3 is a solution to the following system. What does that mean? Let me substitute x is equal to 6 in the first equation and solve for y. And when I solve for y, I get y is equal to -3. In the same way, let me substitute x is equal to 6 in the second equation and solve for y. And again, I get -3. So that means that the point 6, -3 satisfies both equations. And that's why 6, -3 is a solution to this system of equations. Now, how do you solve a system of equations? There are three popular methods. There are other methods beside these three as well, but these are the three methods that we will talk about in this video. The first is solving by graphing. The second is solving by substitution, and the third is solving by elimination. So in this video, we are limiting ourselves to solving equations by graphing. So our objective would be to be able to solve equations by graphing by the end of this video. So let's see what does it mean to solve by graphing. When two or more equations, when a system of equations is graphed, their point of intersection is the solution. So for example, we have these two lines, y is equal to 2x, 2 over 3x minus 7, and y is equal to -x plus 3. So we graph those equations. Here's the first equation, 2 over 3x minus 7. Here's the second equation, the graph of the second equation, and the point where they intersect is the solution to these equations. So I would say that the solution to these equations is the point 6, comma -3. These are the same equations that I had in one of the earlier examples. Now let's take a look at the two definitions here. So when a system of equations has at least one solution, we say that's a consistent system of equations. And if a system of equations has no solution, then that system is called an inconsistent system of equations. So let's take a look at this second example. So the first equation we have is in the standard form. And when I have an equation in the standard form, the easiest way to graph that is to find the intercepts. So let's first find the x-intercept by making y is equal to 0. So I say 5x plus 3 times 0 equals 15, and that will give me x is equal to 3. So I have my x-intercept here, and then in order to find the y-intercept, I am going to make x is equal to 0. So 5 times 0 plus 3y is equal to 15, and that gives me y is equal to 5. So I have the y-intercept as well, and now I can easily join these two through a straight line, and that is a straight line that goes through those 2 points. Now for graphing the second point, the second line, I can start with the y-intercept, which is -4, and then from there use the slope. So go 3 points to the right, So let's go 3 points to the right, and then let's go 5 points down. So 1, 2, 3, 4, 5. So that is my second point. And once I have the second point, all I need is 2 points to draw a line, and I can join them through a line. Now what I realize is that these two lines are actually parallel to each other, and they will never intersect. So there is no solution. So a system of parallel lines has no solution and is inconsistent. Now, this is the next example. I have 2x minus 3y is equal to 6. So I start by finding the intercepts. So first I'll make y is equal to 0 to find the x-intercept. And when I solve for x, I get x is equal to 3. So x is equal to 3, that's the x-intercept. And then I can find the y-intercept by making x is equal to 0. And when I solve for y, I get y is equal to -2. So there is my y-intercept. And now I can draw the line that goes through those 2 points. Now let's see if we can draw the second line as well. So y is equal to 2 over 3x minus 2. The y-intercept is -2. So that's going to be this point again. And the slope is 2 over 3. So starting from here, I go to the right 3 units and I go up 2 units. And this is what I do, go 3 units to the right and then go 2 units up. And what I realize is I have this exact same 2 points. So these two lines actually represent two lines which are overlapping. And since the two lines overlap, therefore there will be an infinite number of solutions. So the given system represents two overlapping lines, and they would have an infinite number of solutions. So that's another type of equations that we need to remember. This is a consistent set of equations. So here's example 4. We want to solve this set of equations. So for the first equation, I see y is equal to 3x plus 10. I start with the intercept, and then I can get another point by substituting any value for x. Let's say x is equal to -2. And when I substitute x is equal to -2, I get y is equal to 4. And since I have these 2 points, I can draw the line through them. For the second line, y is equal to -1 over 5 minus 6. The intercept is, y-intercept is -6, so that's the first point. And the slope is -1 over 5. And what that means is that I would go 5 units to the right, and then I would go 1 unit down because it's a negative slope. And once I have those 2 points, I can join them through a straight line. And then I realize that the point in which they intersect is the point -5, -5. So the solution to this equation is the point -5, -5. So I hope that you liked this video. If you liked it, please hit the like button and subscribe to our channel as well, so you will never miss a video. And if you would like us to make a video on a certain topic, email that topic to us and we'll make that video for you. If there's a problem that you would like us to solve for you and get a video solution, please email that problem to info@sageeducational.com. Again, I hope that you like this video.